Okay, let's actually discover another type of motion that exists, and we haven't actually discussed that since we were discussing linear motion and we were discussing equations for linear motion throughout. But some small concepts of circular motions are also something that you need to be familiar with. So let's actually discuss what is circular motion. So circular motion is that whenever I guess we all are familiar with what are circles, and we don't actually have to explain what is a circle. But circular motion is that anything that is moving in the motion that it is creating a circle, right? It is not creating a straight line. It is not going linearly. It is going circularly. So it is going in a circular motion, right? So for example, something is here, right? This point or this ball is here, and then it goes all the way in a curvature, right? So curvilinear sort of motion, and it goes all the way in this direction. So now it is, we can see that it is actually making some circular motion. It is doing some circular motion, and we need to understand why things actually do this, or make this circular motion. It is because of few reasons. The circular motion is basically happening because there's a constant force that is always acting towards the center of the circle. So for example, this object is moving in this curve. There has to be a center of this circle that this curve is the circumference of, right? So this is, for example, the center of the circle. There has to be a force that is acting towards that center of the circle, because wherever the ball goes, for example, at this point or this point, it stays at a constant distance from this point. So it always wants to have a constant relationship with this point. It always revolves around this central point, but it never actually comes closer or goes away from this point. So there's a force that is actually acting towards this center of the circle, right? And there has to be a force that is causing it to revolve around this. If you just assume the ball to be standing still at this point, and the force was acting towards the center of the circle, it would just eventually come down and hit the center of the circle. But the fact that it is not actually coming down and hitting the center of the circle, and still revolving around the at a constant radius around the central point, is that there's another force which is acting tangentially to the radius of the circle, right? So there is always a force that is acting tangentially to the center of the circle, right? So the force was actually acting in this direction, but there was another force which was actually acting towards the center of the circle. So the resultant of the two forces was in this direction, right? So we have already discussed what a resultant force is, and because of these two forces, in the proportion that these two forces were in, the resultant of the force was actually in this direction. And when the ball reached here, then the force was actually again acting towards the center of the circle, because the source of attraction was there. And then the force that was acting tangentially would actually be acting in this direction, and the resultant force would actually again be acting on this circumference path, right? So this will continue to happen, and the object will be seen to revolve around the central point, and the object will be said to be in circular motion. So this is a general understanding of circular motion, and you can think of it this way. And we'll be talking some details about this in the upcoming video, that what exactly are the scenarios in which circular motion is happening, and what is the force that is actually attracting everything towards itself right in the center in many cases that we observe in our universe.